Hello and a warm welcome to all from SGT University. I am Kaushal Sharma from Department of Civil Engineering. You must have seen structures like bridges, buildings, industries. All these structures are supported by concrete or steel. Look at the small structure of a building. It is having foundation, vertical member called column and a horizontal member such as beam and slabs. Each part has its own significance and utility. Today we will learn about beam. Beam is a structural member of a system having external load at right angle to its axis. You can see dotted line in the axis and load applied at the right angle. There are different types of beams on the basis of support, cross section and geometry. On the basis of support, there are 5 types of beams: simply supported beam, cantilever beam, overhanging beam, fixed beam and continuous beam. Simply supported beam is the beam which is supported or resting freely on the supports at its both the ends. Cantilever beam. It is the beam which is fixed at one end and free at the other end. Overhanging beam. If the end of the portion of the beam is extended beyond the support, such beam is known as overhanging beam. If overhanging is one side, it is called single overhang beam. And if overhanging is on the two sides, it is called double overhang beam. Fixed beam. A beam whose both ends are fixed or built in walls is known as fixed beam. Continuous beam. A beam which is provided more than 2 supports is known as continuous beam. These different beams are supported in a different way according to a different support system. These different supports are simple supports, roller supports, pin joint or hinge supports, fixed or built-in supports. Simple supports are such as, in this case, support will be normal to the surface of the beam. If AB is a beam with the edges A and B, then RA and RB will be the reaction from the two ends of the support. Roller support. The roller is used as an external support since it allows rotation and horizontal translation. Therefore, it will have a vertical support reaction. Here, beam AB is supported on the rollers. The reaction will be normal to the surface on which rollers are placed. Pin joint or hinge support. Here, the beam AB is hinged at point A. The reaction at the hinged end may be either vertical or inclined depending upon the type of loading. If load is vertical, then the reaction will also be vertical. But if load is inclined, then the reaction at the hinged end will also be inclined. A hinge resists horizontal and vertical translation but allows rotation. Therefore, a hinge consists of horizontal and vertical support reaction. Fixed or built-in support. In this type of support, the beam should be fixed. The reaction will be inclined. Also, the fixed support will provide a couple. These different types of beams with different supports undergoes a different type of loading. These different type of loads are concentrated or point load, uniformly distributed load called as UDL as well, uniformly varying load called as UVL. Concentrated or point load is one which is considered to act at a point. In the following example, in a cantilever beam, a load F acts at a point. uniformly distributed load. A load is the one which is spread over a beam in such a manner that rate of loading is uniform along the length of the beam. Usually it refers self-weight of the beam, or it may be also an external loading. Uniformly varying load. A uniformly varying load is one which is spread over a beam in such a manner that rate of loading varies from point to point along the beam. The area of the triangle represents the load intensity and it acts at CG point of the triangle, that is B multiplies by H divided by 2 equals to L multiplied by W divided by 2. It is the load intensity and it acts at CG point as shown. On the basis of cross section, there are two types of beam, T beam and I beam. As you can see from the picture, the cross section of the beam is in shape of letter T. It is called T beam. And the cross section of the beam is in shape of letter I. It is called I beam. On the basis of geometry, there are three types of beams: straight beam, curved beam and tapered beam. This is all about different types of beam. Now we will study about shearing force and bending moment. When a beam which is in equilibrium under a series of forces is cut in some section X and the beam to the left to the section remains in equilibrium, then some forces must act at the section prior to cutting. This force would be provided by the adjacent material and would act tangentially to the section. Hence, there will be a shearing force at the section. Numerically, this shearing force will be given by algebraic sum of the forces to the left or to the right of the section. As the convention, an upward force to the left of the section is counted as producing negative shear force. Similarly, an upward force to the right of the section will produce positive shearing force. Considering further the equilibrium of the material to the left of the section X, it follows that there can be no resultant moment to the left of the section. Hence, any moment produced by the forces acting on the beam must be balanced by an equal and opposite moment produced by the internal forces acting in the beam at the section. This is the bending moment at the section. What is bending? Bending implies deformation of a bar produced by loads perpendicular to its axis, as well as force couple acting in the plane passing through the axis of the bar. Beams, while bending, develop compression and tension. When a beam experiences bending moment due to external load, there is a change in shape, and also due to bending, internal stresses will be developed. There are three types of bending. First is lateral bending. Second is torsional bending. Third one is vertical bending. Now we will discuss about the bending patterns. These patterns are hogging and sagging. Do you know what is hogging and sagging? Look at the shape. When it is curved downward, that is called sagging. And when the shape is curved upward, this is called hogging. Same is applicable to the beam. When load is applied, hogging describes a beam which curves upward, and sagging describes a beam which curves downwards. So today we covered what is beam, different types of beams, shear force and bending moment, and bending. In the next lecture, we'll study about shear force diagram and bending moment. Thank you.